The morning of August 8th, 1940, dawned hot and humid over Kure Naval Arsenal. Workers lined the docks in silence. No cameras, no newspaper reporters, no celebration. Military police watched every entrance. Guards patrolled the waterfront with orders to shoot anyone attempting to photograph what stood before them in the covered dry dock. At precisely 0800 hours, the canopy came down. For the first time, sunlight touched the hull of Yamato. 263 meters of steel. 72,000 tons of ambition wrapped in armor plate thick enough to stop any shell in the world. Workers who'd spent 4 years building her stood watching, sworn to secrecy under penalty of death. Most didn't know what they'd built. They knew their section, their rivets, their welds. Nobody saw the whole picture except the engineers, and the engineers weren't talking. Yamato slid into Hiroshima Bay without fanfare. No speeches about the emperor, no declarations about imperial destiny. The Japanese Navy wanted the world to believe this ship didn't exist. American naval intelligence had heard rumors. A super battleship, displacement unknown, armament unknown, specifications classified at the highest level. But intelligence worked on fragments, decoded messages that mentioned battleship number 1. Reports from dock workers who'd signed non-disclosure agreements but talked anyway after enough sake. Estimates ranged wildly. 45,000 tons, maybe 50, armed with 16-inch guns, possibly larger. Nobody in Washington guessed 18.1 inches. Nobody imagined guns that could throw a 3,200-pound shell 26 miles. Nobody calculated armor 16 inches thick on the belt and 26 inches thick on the turret faces. The Americans were designing the Iowa class, fast battleships, 33 knots, 9 16-inch guns, good armor, excellent fire control, ships designed to fight other treaty battleships in a war where international agreements still mattered. Japan had stopped caring about agreements 3 years earlier. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. On December 29, 1934, the Japanese government formally notified the United States that it would terminate the Washington Naval Treaty. The treaty would expire December 31, 1936. After that date, Japan would build whatever it wanted. The Washington Naval Treaty had been signed February 6, 1922. It was supposed to prevent the naval arms race that everyone saw coming after the First World War. The United States, Great Britain, Japan, France, and Italy agreed to limit their battleship fleets. A ratio system. 5 for America, 5 for Britain, 3 for Japan. Smaller allocations for France and Italy. Battleships couldn't exceed 35,000 tons displacement. Main guns couldn't exceed 16 inches. Existing ships could be kept. Planned ships had to be scrapped. The United States cancelled 30 capital ships under construction. Britain scrapped 23, Japan 17. The treaty also limited where nations could build fortifications. The United States couldn't fortify Guam or the Philippines beyond existing levels. Japan couldn't fortify the Kuril Islands or Formosa. Britain could fortify Singapore. The idea was to reduce tension in the Pacific by making offensive operations difficult for everyone. For Japan, the treaty was humiliation, wrapped in international law. 3-5. 60% of American and British strength. The ratio implied Japan was inferior, less capable, less deserving. Japanese nationalists called it an insult to the emperor. The fleet faction within the Japanese Navy argued that Japan should withdraw immediately and build without limits. The treaty faction argued that staying in the system was strategically smart. America's industrial capacity was vastly larger than Japan's. Under the treaty, America was restricted far more than Japan relative to what each nation could actually build. The treaty capped American potential. Withdrawing from the treaty would unleash that potential. Admiral Isoroku Yamamoto understood this perfectly. He'd served as a naval attaché in Washington. He'd seen American factories. He'd studied American production data. He knew that in an unrestricted building race, the United States could outproduce Japan by margins far greater than 5-3. Yamamoto argued Japan should stay in the treaty system and use the limitations to maintain relative strength. He lost the argument. By 1934, Japanese militarists controlled the government. The Manchurian Incident. The creation of Manchukuo. Japan's withdrawal from the League of Nations. The path toward confrontation with the Western powers was set. Naval Minister Admiral Osumi Mineo threatened to resign if Japan didn't formally end the treaties. Foreign Minister Hirota Koki tried to negotiate a middle path, gradual increases toward parity. The Americans and British refused. Japan wanted equality. The Western powers saw no reason to grant it. On December 19th, 1934, Japan gave formal notice. The Washington Treaty would expire in 2 years. Japan would not renew it. Secretary of State Cordell Hull released a statement expressing regret. The existing treaties had safeguarded the rights and promoted the collective interests of all signatories. Their termination was unfortunate but understandable. Nations had the right not to renew treaties. Nobody in Washington understood what Japan was planning. Design work on the Yamato class had begun years earlier. As early as 1934, before formal withdrawal from the treaty, Japanese naval architects were drawing blueprints for a battleship that violated every treaty limitation. Displacement, 70,000 tons. Main armament, 9 18-inch guns. Armor designed to withstand hits from 18-inch shells at 20,000 to 35,000 meters. Captain Kikuo Fujimoto led the initial design team. 23 different plans were drawn up. 50 experimental ship models were tested in model basins. Every design pushed the limits of what Japanese industry could build. The final plan, designated A-140F6, was approved in March 1937. The logic behind Yamato was simple and desperate. Japan couldn't match American industrial production. America could build more ships, more aircraft, more of everything. Japan's only chance in a protracted war was qualitative superiority. Build fewer ships, but make them so powerful that each one could defeat multiple American vessels. The decisive battle doctrine, Kantai-Kessen, one massive fleet engagement. Japanese superior ships and superior training would destroy the American Pacific Fleet. After that crippling blow, America would negotiate peace rather than endure years of costly war. The entire strategy required battleships powerful enough to win that decisive engagement. Yamato was the answer. Too wide to fit through the Panama Canal, too heavily armed for any American battleship to fight at equal range, designed to engage multiple American battleships simultaneously and win. The keel was laid at Kure Naval Arsenal on November 4th, 1937. The drydock had to be deepened by 1 meter. Gantry cranes, capable of lifting 350 tons, had to be installed. A canopy was erected over part of the construction area to hide the ship from aerial observation. Workers signed non-disclosure agreements before they were allowed on site. Military police monitored everything. Conversations, mail, shore leave. Anyone suspected of leaking information disappeared. Construction took nearly 4 years. The hull alone required thousands of tons of high tensile steel. The armor belt was 18 inches thick. The turret faces, 26 inches. Each main gun turret weighed as much as an American destroyer. The guns themselves were technological marvels. Type 94 46-centimeter naval rifles. Barrel length over 21 meters. Breech mechanism so large it required hydraulic systems just to open and close. Each gun could fire shells in 3 categories: armor-piercing, high-explosive, Sanshikidan incendiary anti-aircraft shells. The armor-piercing shells weighed 1,460 kilograms. They could penetrate any armor afloat. The problem was, they were designed to penetrate battleship armor. Against thin-skinned targets like destroyers or cruisers, the shells would pass completely through without detonating. Armor-piercing shells needed resistance to trigger the fuse. Without thick armor to penetrate, they were just very expensive projectiles. Nobody designing Yamato in 1937 thought this would matter. She was built to fight battleships. That was her purpose. The decisive battle, battleship against battleship, gun against gun, Japanese quality against American quantity. By mid-1941, Yamato was nearly complete. Her main battery turrets were installed, her armor was welded and riveted into place. Her propulsion system, 4 steam turbines generating 150,000 shaft horsepower, was ready for sea trials. In October 1941, she underwent testing and reached 27.4 knots, slower than American fast battleships, but speed wasn't her primary requirement. Firepower was, armor was, the ability to absorb punishment and keep fighting. On December 16, 1941, 9 days after Pearl Harbor, Yamato was formally commissioned. The ceremony was deliberately austere. No press, no public announcement. The Japanese government still wanted to keep her existence secret as long as possible. American intelligence would eventually figure it out, but every month of uncertainty was an advantage. Captain Jihachi Takayanagi took command. Yamato joined battleships Nagato and Mutsu in the 1st Battleship Division. On paper, it was the most powerful surface combat unit in the world. 3 modern battleships, over 200 guns, more than 200,000 tons of warship. On February 12, 1942, Yamato became flagship of Admiral Isoroku Yamamoto's combined fleet. The same Yamamoto who'd argued against leaving the treaty system. The same Yamamoto who understood American industrial capacity better than almost any Japanese officer. Now he commanded from the bridge of a battleship that represented everything he'd warned against. A ship so expensive that losing her would be a national catastrophe. A ship so valuable she couldn't be risked in combat unless the situation was desperate. That was the fundamental contradiction of Yamato. She was designed for the decisive battle, but she was too valuable to risk until that decisive moment arrived. And the decisive moment kept not arriving. The Battle of Midway, June 1942. Yamato was there. She sailed with the main battle group. Admiral Yamamoto directed the operation from her bridge. She never fired her guns. The battle was fought by carrier aircraft 300 miles away. By the time Yamamoto understood the disaster unfolding, his carriers were burning, and Yamato was too far away to intervene. She withdrew with the main force. Her 18-inch guns hadn't contributed anything. After Midway, Yamato spent months moving between Truk and Kure naval bases, waiting, training, consuming fuel oil that Japan could barely afford to spare. Waiting for the decisive battle that never came. In November 1942, the naval battle of Guadalcanal destroyed Japanese hopes of retaking Henderson Field. 2 night battles. American and Japanese ships fighting at point-blank range in Iron Bottom Sound. Searchlights, torpedo attacks. Battleship Hiei crippled and scuttled. Battleship Kirishima destroyed in 7 minutes by radar-directed gunfire from USS Washington. Yamato was at Truk, 800 miles away. Too far to help. Her 18-inch guns silent, while Japanese battleships burned. That battle changed everything. Not because of what happened to Hiei or Kirishima. Those losses were devastating, but understandable. What changed everything was how Kirishima died. USS Washington had radar, fire control radar. The Mark III system, later upgraded. The ship could track targets in complete darkness, calculate range electronically, direct guns using data from radar operators rather than visual observation. Admiral Willis Lee commanded Washington. He understood radar better than any flag officer in the United States Navy. He'd spent years studying the technology, training his crews, developing tactics specifically designed to exploit radar's advantages. On the night of November 14th, 1942, Lee demonstrated what radar could do. Kirishima never saw Washington until American shells were already hitting. The engagement lasted 7 minutes, 9 salvos from Washington's 9 16-inch guns. At least 9 direct hits on Kirishima. Probably more. Hits on the steering gear, hits on the engineering spaces, hits on the superstructure. Kirishima was crippled, burning and sinking before her crew understood what had killed them. Japanese after-action reports describe confusion, shells arriving from darkness, no visual contact with the enemy, Kirishima's optical rangefinders useless in pitch-black night, her fire control systems relying on visual observation that provided no data. She fired back at muzzle flashes when she could see them. Most of her shells missed by hundreds of yards because her fire control solutions were based on guesses. Washington hit because her radar provided exact range. Her fire control computers calculated firing solutions from electronic data. Her guns trained on coordinates provided by radar operators who could see Hiroshima clearly on their scopes, even though the target was invisible to human eyes. The decisive battle had come. Not in daylight with proper visibility where Japanese optical equipment and training would provide advantage. It came at night in Iron Bottom Sound, where electronics defeated experience. 3 months earlier, Japanese forces had dominated night surface combat, the Battle of Savo Island, August 9, 1942. Japanese cruisers surprised an Allied force and sank 4 heavy cruisers in 32 minutes. Superior night optics, intensive training in low-light conditions, aggressive doctrine. The darkness was Japan's ally. After Guadalcanal, the darkness belonged to whoever had better radar. American naval doctrine changed immediately. Ships that had been using radar for detection and warning started using it for primary fire control. Combat information centers were created to coordinate radar data and maintain complete tactical pictures. Training programs taught operators how to track multiple targets, how to distinguish ships from land returns, how to spot shell splashes on radar screens and correct fire without visual observation. By mid-1943, every major American warship had multiple radar systems: surface search, air search, fire control. The SG surface search radar, operating at 10-centimeter wavelength, provided range accuracy within 40 yards. The Mark 8 fire control radar could spot 16-inch shell splashes at 20,000 yards and track them to at least 35,000 yards. American battleships could engage targets beyond the visual horizon, in darkness, through smoke. In weather that made optical fire control impossible, Japanese radar development lagged years behind. Early systems were primitive, short-range, poor resolution. Fire control radars weren't deployed to fleet units until 1943, and even then, they were less capable than American systems from 1942. The Mark II shipboard search radar was crude. Effective range against capital ships, maybe 20,000 yards. No plan position indicator display. Operators had to interpret returns on oscilloscopes that showed spikes rather than tactical pictures. More critically, Japanese tactical doctrine never fully integrated radar. It remained an auxiliary system, a backup to visual observation. Japanese officers trusted their eyes more than electronics. They'd trained for decades using optical equipment. The cultural shift required to trust machines over human senses was difficult. American officers made that shift in months. Japanese officers never completely did. This technological and doctrinal gap doomed Japanese surface forces. Battle after battle, American radar defeated Japanese training. The Battle of Vela Gulf, August 1943. American destroyers, using radar, detected Japanese destroyers at long range, maneuvered into position, and destroyed 3 enemy destroyers with radar-directed torpedo attacks before the Japanese knew Americans were present. The Battle of Empress Augusta Bay, November 1943. American cruisers and destroyers defeated a Japanese force using radar-directed gunfire. The Battle of Cape St. George, November 1943. American destroyers intercepted and destroyed 3 Japanese destroyers in a night action entirely controlled by radar. American losses in these engagements were minimal. The Japanese couldn't match what they couldn't see, and Yamato sat in port, Kure, Truk, Brunei, moving between bases, consuming fuel, training crews, waiting for the decisive battle in the open ocean where her 18-inch guns would matter. That battle never came. The nature of naval warfare had changed, not gradually, overnight. Midway proved that carriers had replaced battleships as the decisive weapon. Guadalcanal proved that radar had made night combat an American advantage. The strategic situation Japan envisioned in 1937, when Yamato's keel was laid, no longer existed. By December 1943, Yamato had been in service 2 years. She'd fired her main battery at enemy surface targets exactly 0 times. She'd been torpedoed once by American submarine USS Skate on December 25th while transporting troops to Truk. The torpedo hit caused flooding, 3,000 tons of water. Temporary repairs at Truk, then full repairs at Kure that lasted until February 19, 44. She was refitted during those repairs. Additional anti-aircraft guns, 162 25mm weapons by the time work was finished. Her radar systems were upgraded, but the fundamental problem remained. She was a battleship designed for a kind of warfare that didn't exist anymore. The Philippines Campaign. October 1944, Yamato finally fought the Battle off Samar. For the first and only time, she fired her 18-inch guns at enemy surface units. The target wasn't a battleship, it was escort carriers, destroyer escorts, ships with 5-inch guns, and maybe 1 torpedo mount. Yamato opened fire at 33,000 yards. The shells were color-coded with dye, so Japanese spotters could distinguish splashes. Pink for Yamato, yellow for Nagato, red for Haruna, green for Congo. The colored geysers rose around American ships that couldn't fight back at that range. Yamato hit escort carrier Gambia Bay multiple times, 18-inch shells, but they were armor-piercing shells designed to penetrate battleship armor. They punched through Gambia Bay's thin hull and exploded in the water on the other side or detonated inside unarmored spaces without causing catastrophic damage. The shells were too powerful for the target, like using a .50 caliber armor-piercing round against unarmored infantry. It'll kill, but it's wasteful overkill when a rifle bullet would work better. Then, American destroyers launched torpedo attacks. USS Johnston, USS Howell, USS Herman, tin cans charging battleships, suicidal courage, desperate aggression. They forced Yamato to maneuver, turn away from torpedo spreads, break formation, lose contact with other units. Admiral Kurita, commanding from Yamato, lost tactical control of his force. He thought he was fighting fleet carriers and heavy cruisers. He ordered a general attack, every ship for itself. The formation dissolved. Yamato spent part of the battle steaming north to avoid torpedoes. By the time Kurita regained control and reformed his units, he'd lost 3 heavy cruisers to air attack and destroyer action. He believed he'd inflicted massive damage on American fleet carriers. In reality, he'd sunk 1 escort carrier and 3 destroyers. The troop transports in Leyte Gulf, the actual targets of the operation, were untouched. Kurita ordered withdrawal. Yamato retired. She'd fired her 18-inch guns in combat. She'd hit targets. She hadn't achieved anything strategic. The invasion proceeded. The Philippines campaign continued. Japan's situation worsened. After Samar, Yamato returned to Kure. The combined fleet was shattered. Fuel was scarce. American air power dominated. Yamato sat in port, too valuable to use, too expensive to lose, waiting for an opportunity that would never come. By April 1945, the situation was desperate. Okinawa, American forces landing. The invasion of the home islands was clearly next. The Japanese Navy had almost nothing left. A handful of destroyers, a few cruisers. Yamato, Operation Tengo, a suicide mission. Yamato would sail to Okinawa with a light cruiser and 8 destroyers. She'd beach herself, use her 18-inch guns to support the defense of Okinawa until she was destroyed. One-way mission. Fuel was allocated for the trip to Okinawa, but not the return journey, though post-war evidence suggests she actually received more fuel than officially authorized. She departed Tokuyama on April 6, 1945. American submarines detected the force immediately. American codebreakers had already decrypted Japanese communications about the operation. They knew Yamato was coming. They knew her mission. They knew everything. Admiral Raymond Spruance ordered 6 battleships to prepare for surface engagement. Battleships West Virginia, Tennessee, Maryland, California, Pennsylvania, New Mexico. All older ships, Pearl Harbor veterans modernized, equipped with the latest radar systems, the Mark 8 fire control radar, the best gunnery systems in the world. The battleships never fired. Vice Admiral Mark Mitscher, commanding Task Force 58, preempted Spruance. Carrier aircraft, wave after wave. 386 aircraft from 15 carriers, bombers, torpedo planes, fighters. The first aircraft made contact at 0823 on April 7th. Yamato fired her 18-inch guns using special Sanshikidan anti-aircraft shells. Each shell carried 900 incendiary tubes. They exploded at altitude, creating cones of shrapnel and fireballs. Impressive pyrotechnics, ineffective against aircraft that could see the shells coming and maneuver away. The first major attack came at 12:20 on April the 7th. Yamato was still 270 miles north of Okinawa and 386 aircraft. They attacked in coordinated waves. Dive bombers from high altitude, torpedo planes from wave-top height. The attacks were simultaneous, overwhelming, precise. Yamato tried everything. Anti-aircraft fire, evasive maneuvers. Her captain, Rear Admiral Kosaku Ariga, was skilled. He turned the ship continuously. Maximum helm angles, speed changes, anything to throw off aim. It wasn't enough. The first bombs hit at 12:41. 2 bombs destroyed anti-aircraft mounts. A third hit the radar room. At 12:45, a torpedo hit the forward port side. Flooding began. More torpedoes followed. More bombs. The ship developed a list to port. Damage control flooded starboard compartments to correct the list. The corrections worked temporarily. Then the second attack wave arrived. 110 aircraft. They concentrated entirely on Yamato. 20 torpedo planes attacked from the port side. 3 torpedoes hit amidships. Her auxiliary rudder jammed hard to port. She started turning in circles. More bombs, more torpedoes. The list increased. 10 degrees, 15, 20. Damage control couldn't compensate. Water was flooding into too many compartments. The ship was dying. At 14:05, the list reached 35 degrees. Ariga gave orders to abandon ship. Most of the crew couldn't escape. The ship was rolling. Compartments flooded. Watertight doors were jammed or destroyed. Men trapped below couldn't reach topside. At 14:23, Yamato capsized. The list reached 90 degrees. She rolled, completely over. Then, her forward magazines detonated. The explosion was visible for miles. A mushroom cloud rose thousands of feet. The blast wave damaged American aircraft overhead. When the smoke cleared, Yamato was gone. 2,498 men went down with her. Vice Admiral Seiichi Ito, Captain Ariga, most of the crew, 246 men, were rescued. The largest battleship ever built, the most heavily armed, the most powerfully protected, sunk by aircraft. Never engaged another battleship in combat, never fought the decisive battle she was designed for. The irony was complete. Japan spent years and enormous resources building the ultimate gun platform. By the time she was ready, American radar had already made the decisive surface battle obsolete. When Yamato finally fought, it wasn't against battleships with 16-inch guns. It was against destroyers at Samar and aircraft at Okinawa. Neither engagement used her strengths. Both exposed her weaknesses. 3 years earlier, in November 1942, USS Washington had proven that radar defeated even well-trained ships with good optical equipment. That single 7-minute engagement at Guadalcanal changed naval warfare more than any technological development since the dreadnought. Yamato's designers in 1937 couldn't have predicted it, but by 1942, the evidence was clear. Electronics had replaced optics, radar had replaced visual observation. The Navy that mastered radar would control the seas. Japan never mastered it. Japanese radar remained inferior. Japanese doctrine remained tied to traditional methods. Japanese officers remained skeptical of technology they didn't fully understand. By the time they recognized what had changed, it was too late. The war was lost. The fleet was destroyed. Yamato was at the bottom of the ocean. The battleships, Admiral Spruance, ordered to intercept Yamato, never got their chance. That fact tells you everything about how naval warfare had changed. 6 American battleships, all equipped with Mark 8 fire control radar, all capable of engaging targets at ranges beyond 30,000 yards in complete darkness or through smoke. All veterans of previous surface actions where radar had proven decisive. The Battle of Surigao. Strait, October 25th, 1944. 6 American battleships crossed the T on a Japanese force attempting to enter Leyte Gulf. West Virginia, Tennessee, and California had Mark 8 radar. They acquired targets first. They fired first. They achieved devastating accuracy at ranges exceeding 21,000 yards. The Japanese ships, relying on optical fire control, never established effective return fire. The engagement lasted less than an hour. Battleship Yamashiro sunk. Battleship Fuso sunk. Multiple cruisers and destroyers destroyed. American losses were minimal. That was the kind of engagement Yamato was designed for. Line of battle, gun against gun. But with radar, it became a massacre. The American battleships could see everything, track every target, coordinate fire. The Japanese could barely see anything. Their optical rangefinders were useless at night. Their fire control solutions were guesswork. They fired at muzzle flashes and hoped. Yamato would have fared no better. Her 18-inch guns gave her range advantage in daylight. But at night, against radar-equipped American battleships, range didn't matter. The Americans could hit targets they couldn't see. Yamato couldn't hit what her optical systems couldn't track. The Mark 8 radar could spot shell splashes and correct fire automatically. Yamato's fire control required visual observation of splashes, which was impossible in darkness. Admiral Lee's victory at Guadalcanal in November 1942 had proven the principle. By October 1944 at Surigao Strait, the Americans had perfected the execution. Radar-directed fire control had become so effective that surface engagements against non-radar-equipped opponents weren't battles. They were target practice. The Japanese understood this after Guadalcanal. That's why Yamato spent most of the war in port. Her commanders knew she was vulnerable, not to enemy battleships in daylight gunnery duels. In that scenario, she might have advantages, but to night attacks by radar-equipped forces, to submarine attacks by boats that could track her movements through signal intelligence, to air attacks by carrier aircraft that could find her anywhere. She was too valuable to risk, too expensive to lose, too symbolic to waste. So she sat, Kure, Truk, Brunei, thousands of tons of capability, doing nothing except consuming fuel that Japan desperately needed elsewhere. This was the ultimate failure of the super battleship concept. Yamato was so powerful, she became irreplaceable. Losing her would be a national catastrophe. Therefore, she couldn't be used except in the most desperate circumstances. But by the time circumstances became desperate enough to justify risking her, the strategic situation had already deteriorated beyond the point where one battleship could make a difference. At Samar, she fought because Admiral Kurita's force encountered an unexpected target: American escort carriers, destroyers, ships that shouldn't have been there. The engagement was confused, chaotic. Kurita thought he was fighting fleet carriers. He ordered a general attack. Formation discipline broke down. Yamato maneuvered to avoid torpedoes and lost contact. Her 18-inch guns hit targets but didn't achieve decisive results because the ammunition was wrong for the targets. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. At Okinawa, she sailed because there was nothing left to lose. The war was lost. The fleet was destroyed. The invasion of Japan was imminent. Operation Tengo was a death ride, a symbolic gesture. Beach the largest battleship ever built on Okinawa. Use her as an unsinkable fortress. Fight until destroyed. Die gloriously defending the homeland. It was romanticism substituting for strategy. Yamato never reached Okinawa. She never beached herself. She never used her guns to support the defense. American carrier aircraft found her 270 miles from her destination and killed her in under 2 hours. 10 torpedo hits, 7 bomb hits, possibly more. The ship capsized and exploded. Most of her crew died. The Americans lost 10 aircraft, 69 aircrew, a tiny fraction of the attacking force. The exchange ratio was absurd. A 72,000-ton battleship that cost as much as several aircraft carriers, thousands of highly trained crew members, all of it destroyed by aircraft that cost perhaps $1 million each and were flown by pilots with maybe 1 year of training. That was the lesson of the Pacific War. Capital ships were no longer capital if they couldn't defend themselves against air attack. Battleships designed to fight other battleships were irrelevant in a war dominated by carrier aviation. And even in surface engagements, the advantage had shifted to whoever had better electronics rather than bigger guns. The American fast battleships of the Iowa class understood this. They were designed in the late 1930s, around the same time as Yamato, but they incorporated different assumptions. Speed was critical. 33 knots versus Yamato's 27. Fire control was critical. Advanced radar systems integrated into fire control computers from the beginning rather than added later as afterthoughts. Anti-aircraft capability was critical. Dozens of 5-inch dual-purpose guns and countless 40mm and 20mm weapons. The Iowas were designed to escort carriers, screen them from air attack, provide anti-aircraft defense, engage surface threats if they appeared, but primarily keep the carriers safe so the carriers could project power. The battleships were supporting assets, not the main striking force. Yamato was designed to be the main striking force. She embodied the decisive battle doctrine. One climactic engagement, Japanese quality defeating American quantity. After the victory, negotiate peace from a position of strength. The decisive battle never happened, not the way Japan envisioned it. Midway was decisive, but it was fought by carrier aircraft. Guadalcanal was decisive, but it was a grinding campaign of attrition. Leyte Gulf was decisive, but by then Japan's fleet was already crippled and American superiority was overwhelming. In none of these engagements did Yamato's 18-inch guns matter. She was present at Midway, but too far away to engage. She was absent at Guadalcanal. She fought at Leyte Gulf, but achieved nothing strategic. She died at Okinawa without firing a shot at enemy warships. The contrast with USS Washington is instructive. Washington was commissioned July 1942. She fought her first major surface action, November 1942, at Guadalcanal. 7 minutes of combat, 9 salvos from her main battery. Kirishima sunk, Washington undamaged. The engagement demonstrated everything American naval doctrine was becoming: radar-directed fire control, superior electronics, integrated systems that worked together seamlessly, trust in technology over tradition. After Guadalcanal, Washington spent 3 years in the Pacific. She screened carriers. She bombarded shore positions. She provided anti-aircraft defense. She participated in every major campaign from Guadalcanal through Okinawa. She was never hit by enemy fire. Not once. She was in constant action, but survived because American doctrine used battleships intelligently. They weren't sent on suicide missions. They weren't held back for decisive battles that never came. They were used as part of an integrated force structure where every ship type had a role. Washington was decommissioned June 1947 and scrapped in 1961. Not glorious, not romantic, just obsolete. Technology had moved on. Missiles and jet aircraft had made gun-armed surface ships outdated except for shore bombardment. But she'd served her purpose. She'd fought when needed. She'd won her engagements. She'd survived the war. That was success. Yamato's story was tragedy, built to embody Japanese naval supremacy, designed to win the war in one decisive blow. Instead, she spent most of the war hiding. When she finally fought, the world had changed. The decisive battle she was designed for had become impossible. American radar made night combat suicidal for ships without equivalent electronics. American carrier aviation made sailing anywhere within aircraft range suicidal for ships without air cover. American submarines made any movement suicidal for ships without strong escorts and good intelligence security. Japan's fundamental error was building for the war they wanted, Rather than the war they would get, they wanted a climactic battleship engagement in open water where superior Japanese ships and training would defeat numerically larger American forces. They built Yamato to win that engagement. They invested enormous resources, years of construction, thousands of workers, materials that could have built multiple carriers or cruisers or submarines, and the war didn't cooperate. It became a carrier war after Midway, a submarine war in which American boats strangled Japanese commerce, a grinding war of attrition in which American industrial capacity produced ships faster than Japan could sink them, an electronics war in which American radar gave overwhelming advantages in night combat and fire control, a war where the decisive battle doctrine was obsolete before the first shot was fired. Admiral Yamamoto had warned this would happen. He'd argued Japan should stay in the treaty system. He'd predicted that unrestricted competition would favor America's vastly larger industrial base. He had been overruled by nationalist politicians and fleet faction officers who believed Japanese spirit could overcome American material advantages. Yamamoto commanded Yamato at Midway. He watched his carrier force burn while his battleships steamed helplessly hundreds of miles away. He understood what it meant. The war would be won by carriers and aircraft, not battleships and guns. He understood Japan was losing. He understood that Yamato, the ship he commanded from, the most powerful battleship ever built, was already obsolete. He died April 18th, 1943. American fighters intercepted his transport aircraft over Bougainville. He was killed in the crash. He never saw Yamato fight. He never saw her sink. Perhaps that was fortunate. He would have understood the symbolism. The most powerful battleship in the world destroyed by the kind of air power he'd always believed would dominate the Pacific War. The wreck of Yamato was discovered in 1985 by researchers led by oceanographer Yutaka Kaku. She lies upside down in approximately 3,500 feet of water. Her bow section is missing, blown off by the magazine explosion. Her anchor chain is wrapped around her stern. Multiple large holes mark where torpedoes and bombs hit. After more than 70 years underwater, she remains a tomb for the 2,498 men who died with her. Japan memorializes Yamato. The Yamato Museum in Kure displays a 1/10 scale model. Films depict her final voyage as noble sacrifice. She represents Japanese determination, willingness to fight to the death, the tragedy of warriors destroyed by overwhelming enemy power. That narrative misses the point. Yamato wasn't destroyed by overwhelming enemy power. She was destroyed by obsolescence. She was designed to fight a war that never existed. By the time she was commissioned, the kind of surface engagement she was built for had already been made obsolete by developments in radar technology and carrier aviation that Japan either couldn't match or refused to prioritize. U.S. Washington proved in November 1942 that electronics defeated experience in night combat. That single engagement changed everything. The Americans understood immediately. They invested in radar. They developed doctrine. They trained crews. They integrated the technology into every aspect of naval operations. Within a year, American superiority in night surface combat was absolute. The Japanese never caught up. They developed radar, but it was always inferior. They deployed fire control systems, but officers didn't trust them fully. They maintained traditional doctrine, emphasizing visual observation and optical instruments. By the time they recognized the gap, it was too late. American radar-equipped ships controlled the night. American carrier aircraft controlled the day. Japanese surface forces couldn't operate safely in either condition. Yamato's 18-inch guns were the largest naval rifles ever built. They could throw shells 26 miles. They could penetrate any armor. They represented the peak of battleship gun development. And they were irrelevant. Not because they didn't work. They worked perfectly. But because the war wasn't decided by who had the biggest guns. It was decided by who had better radar, better carriers, better submarines, better logistics, and vastly superior industrial production. Japan bet everything on quality defeating quantity. They built super battleships. They trained elite pilots. They developed superior torpedoes. They perfected night combat techniques. All of it was impressive. None of it was enough. America's industrial capacity produced ships and aircraft faster than Japan could destroy them. American electronics gave advantages that Japanese training couldn't overcome. American doctrine adapted to new technologies while Japanese doctrine remained tied to tradition. The result was inevitable. Japan lost. Yamato sank. The decisive battle never came. The lesson isn't that battleships were obsolete. USS Washington and the other American fast battleships served effectively throughout the war. The lesson is that weapons platforms must match the war you're actually fighting, not the war you wish you were fighting. Yamato was designed for a war of climactic surface engagements. That war didn't exist. She was too valuable to risk in the actual war of attrition, carrier strikes, and submarine interdiction. So she sat in port consuming resources until desperation forced her into a suicide mission. Admiral Lee's faith in radar technology at Guadalcanal was vindicated 1,000 times over. By war's end, every major American combatant had multiple overlapping radar systems. Combat information centers coordinated information and presented complete tactical pictures. Fire control computers integrated radar data automatically. Ships could fight in any visibility conditions. They could engage targets beyond the horizon. They could maintain accurate fire while maneuvering at high speed. This was the future Japan failed to embrace, not because they lacked the technical capability. They developed radar. But they developed it late, deployed it half-heartedly, and never fully integrated it into their doctrine. Officers trained for decades in traditional methods couldn't make the psychological shift to trusting electronics over their own eyes. The Americans made that shift in months. Admiral Lee made it first at Guadalcanal. Within a year, the entire fleet had followed. That adaptability, that willingness to abandon traditional methods when new technology proved superior, was as important as the technology itself. Yamato's story is a reminder that military power isn't just about having the best weapons. It's about having the right weapons for the actual conflict. It's about adapting to technological change. It's about doctrine that matches capabilities to strategic requirements. It's about understanding what kind of war you're fighting and building forces appropriately. Japan built for yesterday's war. Battleships, decisive engagements, quality over quantity. By the time Yamato sailed, the war had moved on. Carriers, radar, attrition, industrial capacity, electronics, all the things Japan underinvested in because they conflicted with traditional doctrine and national mythology about spiritual superiority. American radar didn't just defeat Yamato's guns, it defeated the entire strategic concept behind Yamato's existence. The decisive battle doctrine, the super battleship philosophy, the belief that technological supremacy in big guns could compensate for industrial inferiority. Admiral Lee understood this in November 1942. He trusted his radar completely. He trained his crews to fight using electronics as their primary sensor. He proved the concept worked. Everything that followed was application of that principle. Yamato's designers understood warship engineering. They created a masterpiece of naval architecture, but they designed for a war that was already obsolete before their ship was launched. That was the tragedy. Not that Yamato was poorly designed. She was brilliantly designed. But she was designed to win the wrong war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.